Alright, so my name is Angelo. I'm going to be showing you the components of a carrier system and what they do. We're going to go ahead and test them, pretty much see the performance of the system and know a little bit more about it. So we're going to kind of go over basically what you have here on this furnace. So we're going to start with this system. This is your Carrier Weathermaker 8000, just a basic standard furnace. It's not a 90%er, it's a 80% furnace. That means it's non-condensing, and we'll go over that here in a little bit. Also, you have a coil, which is going to be your refrigeration part. This one's on the bottom of the furnace, so this is going to be considered a downflow, since the air comes through the top of it and blows downwards through the coil, which has refrigerant running through that. It provides cooling for your house. And then down here we have a UV light that's installed underneath the coil to help with indoor air quality. Okay. As well, on this system right here, from what we can see so far, we also have a filter dryer that captures any debris in the refrigeration line, moisture. Also, you have a TXV that meters the refrigerant depending on the temperature of the actual suction line of your coil, and that just helps the system cool efficiently. Rather than just sending in one fixed flow, this one kind of, I would say, modulates. Okay. So we're going to go ahead and open the furnace up now and learn a little bit more about that. On this furnace, you have some safety instructions on the gas valve, the operating procedures. Okay, on the back of it. So you're going to go ahead and find your model number right here. On this carrier unit's upside down, but on the model number we're going to be able to look at a couple things. We're going to want to write down the model number for service reasons. Let's just say we want to come back to the job. But before we come back to the job to do the repair that we're needing to do, we have the model number already in hand at the shop, in file, or in our database, so we can go ahead and order a part, have it before we get to the job. So that's why it's important to have the model number and the serial number, which is going to be on this unit here. On some other units it's on the inside, but on this one it's here. Again, we also have charts that you can look at different brands, and it tells you on the serial number, I think it's the third or fourth digits, how old the system is. So by having that information, we'll know how old the system is and what parts are needed for that particular system, so it's not a waste of time of telling the customer that we got to run back to the job to get the model and serial number. So we're going to definitely want to get that. This system here is going to have a control board that's going to give us an LED diagnostic, so if something goes wrong with the board, the light's going to start to blink and tell us that there's an issue with the board. And then we can go to our diagnostics and our service sticker here and count the blinks on the board, and it'll give us a good indication and save some time by telling us what has been going on. So the customer might just know their furnace is just not working, but we're able to see a little bit more just by looking at this light. That's if the customer hasn't reset the system. Some systems will hold the actual error codes, and you got to look in here, read the service sticker, how to go back in and look at the error codes. And if you don't find it here, you'll find it in the owner's manual. And if you can't find the owner's manual, then you got to Google the model number and see if you can pull up a PDF file with the service manual or owner's manual. It's actually going to be in the service manual for sure. Okay, so we're going to go ahead and remove this cover here. I'm going to go ahead and grab some tools. You get a picture of the tools we have here. So most importantly is going to be your meter. You definitely want to have a nice meter on hand. Okay, get that, set that right here. We need a 6-in-1. It's like my favorite tool, just because you have different sizes of bits on this. So we're going to go ahead and remove this cover here. You can come in here and zoom in on that LED light so you see that you have an LED light right in there before I take this panel off. Okay, so that's the LED light that we would actually use for checking the code. Now going into this furnace here, behind that panel we have our blower motor and our filter, which just came down here. I'm going to go ahead and remove this filter for now. Okay. Alright, so we'll kind of start from the top and then work our way down. This side of the furnace is our return air. So this is kind of where the filter is going to go back in here, or you're going to have a filter rack built on top of the furnace, or you're going to have it in a return air filter grill, which is going to be right above us. And you can take a look up here. See a return air filter grill. In this case, the filter is installed in the cavity here in the furnace. So after that return air filter, then we have our blower motor. Okay. On this blower motor, we're going to have a capacitor. But before we get in here and start touching everything, even though the power is off because of the door switch, which we will explain here in a minute, I'm going to want to just unplug everything for safety reasons. And it's very important that we remember to plug everything back in when we're done. Okay? So now that I got the system unplugged, now I can, go ahead and mess with some of the components in here safely before I put my hands on. So after the filter grill, then there's our blower housing. We call these squirrel cages, or blower housings. Okay, this is going to be where our motor is back in here. And one of the things that when we're doing maintenance or service we want to look at is the condition of that motor. Whether the actual motor is full with lint, dust, debris. Sometimes stuff gets caught in there. I mean, you'd be surprised even mouses crawl in there somehow. But we want to check that out. We want to look in there, make sure everything's moving freely. The motor wheel's moving freely. Now that's why I say make sure we turn the power off, because we don't want that turning on and catching our hand in there. Okay, so I'm gonna go ahead and put a flashlight in here. You kind of see the blower housing in here. You get a little bit closer. And then the squirrel cage, which is a wheel that actually spins and has louvers in it, is going to be on this side. You can get that camera in here and take a look and see if you can see that wheel there. And I'll go ahead and spin that wheel. We want to make sure that's really clean. If not, we want to recommend a blower cleaning, which means removing the actual motor and the housing out and cleaning that up. Basically, compressed air works good. If you want to rinse it, we got to make sure that we either got to pull the motor out or cover the motor up safely so the motor doesn't get wet. That's why compressed air is probably going to be a good bet. But you don't want to do that while it's in here, right? Because we're going to get all that dust and debris into the wind stream of the ductwork, and then into the home, and then you got a complaint, right, from the customer. This guy was messy. He got everything in my house, and who knows, we get that dust all over paintings and furniture. So there you have it. That's your blower wheel back in here, and then you got your motor. Okay. And now on this motor and this housing, we have something called a run capacitor. That run capacitor, what that does, it helps the actual motor run, right? Helps it run without any problems, so it doesn't overheat. And so with this run capacitor, I think it's actually correcting the voltage. So it's actually help correcting the voltage. But there's some terminology behind it that we can look up. But at this moment, this helps the blower actually run. Okay? And on that capacitor, if this is low or out of range, what happens is this motor will actually have high amps and overheat. Okay? And when it has high amps and overheat, it might shut off and just not work, and it's going to be really hot to the touch. And they're going to call that internal overload, which is protecting itself. So we would have to let that motor cool down, okay, before we can see if it's going to work. But in order for us to see if it's going to work, we got to make sure that the capacitor is good, right? So the way we check these capacitors, I'm going to go ahead and remove it. Okay, I never want to touch these wires because this capacitor stores electricity in it to help the motor run. So if I touch these, there's a good chance I can get shocked. So what I want to do is I can run an insulated screwdriver. Okay, make sure you have a rubber insulated screwdriver, you're not getting metal, and run it across here. Sometimes you might see a little pop or something like that. That's especially if the power is still plugged in. But if it's storing charge, it can do that. But by doing this, we're shorting the capacitor, bleeding the voltage out of it, making sure that we're not going to get shocked. Okay, so we make sure that's done. I believe they do sell bleeders still. I've never used one, but I've heard of them. So that it's an actual tool that will help bleed out a capacitor. So when I'm looking at this, I got to really make sure that somebody didn't come in here and kind of, just throw on a capacitor. Maybe if I asked the customer to find out what's the history, or does anybody worked on it, I can find out if another company was in here and they put the wrong capacitor. So maybe that's why the motor's not working or it's burned out. But if it is original capacitor or nobody's replaced it recently, what I'm going to look at it is if I can get to the actual sticker on the motor, it'll tell me what size capacitor it needs and what voltage. Okay, on this capacitor, if you look at this sticker a little closer, you can get closer here. This says this capacitor is 370 volts and it's 10 UF. Okay, and then it says plus or minus 6%. So I know that this system is only a 120 volt system. So this capacitor would definitely handle it. But what if I put this capacitor on a commercial building that was actually over 400 volts? I believe it's 440 on the capacitance, or 470. So if it was over, and I put this capacitor on a higher voltage over 400, that's not a good idea. It's not going to work right. So what I'm going to want is I rather, if I'm on my truck, I might want to carry just 400 plus. And let me double check on it real quick. Can't remember off the top of my head, so. I believe it's 440, but I can't find it. But let's move on from there. But on the capacitor, if you carry the higher voltage one, then you can use it for both of them. Okay, but you can't take the 370 and put it on I believe it's a 440 volt system. Okay, so now that we know the UFs, which is 10 UFs, and then the voltage, and then plus or minus 6%. What I'm going to do now is I'm going to go ahead and remove this capacitor by taking off the leads. I still just use my screwdriver just for safety. Okay. I'm going to take off these leads. So I got my capacitor there. I'm going to grab my meter down here and connect my meter leads and get it ready. I hope this battery's charged. I know the battery was dying here the other day. So I'm going to go ahead and change this meter to MFDs, which is microfarads, and that reads UFs, which is for the capacitor. So when I'm reading that on the meter, okay, here it actually has a magnet here on this one. Put that right there, so that kind of helps. So what I'm looking for is the capacitance. So this says that this capacitance is 9.2. Okay, so then what I'll do is I'll go ahead and go to my calculator, and this says 10 UFs, but it's reading 9.2. So I'll know that it's supposed to be within 6% of range. So if I have 10 minus 6% equals 9.4. So it's under capacitance. So I'm going to go ahead and recommend you replacing this capacitor. Okay? Because I could be saving the motor. Now, if the motor is bad, if I put a new capacitor and that motor, because that motor was overheated and I checked the capacitor and I got 9.2, and if I put a new capacitor and the motor turns on after it cools off and it's working, then I'm going to want to do an amp draw on the motor and make sure that the motor is not overamping and it's not overheating again. Okay? Because it might be that the capacitor caused the motor to run hot too much, overamp, and now the motor's bad, so now we got to replace the motor and the capacitor. Now, anytime you're replacing the motor, we always want to make sure it's just rule of thumb to replace the capacitor as well. So, you don't want to put a new motor in there and it craps out in 6 months. We want it to last a long time. But another thing we look for, typically, whenever we got a motor call or a compressor call or a fan motor call for the condenser, one of the things I look for is if these capacitors are swollen and they look like they're like you take a soda can and put it in the freezer and it's going to explode, right away you'll know that the capacitor is going bad, right? Or there's oil bleed. Even if it's reading right, and there's a reading and it's 10 UFs and it's reading 10 UFs, or it's 15 UFs and it's reading 15 UFs, if I see oil, that's telling me that the oil is leaking out of the capacitor, so I'm going to want to recommend a capacitor anyways. Okay, so I'm going to go ahead and connect this back up. Actually, we'll set this aside for right now. So that's going to be our blower housing. And then our motor is inside of here. So we looked at that. So also on this system, we have our control board right here. And this is going to be where our terminals are for our thermostat wires. We have 2 wires coming from our air conditioner outside. That goes to the outside contactor, and these 2 wires, one of them connects to our common, and then the other one connects to our Y, which is going to be for our cooling. And then we have our other thermostat wires, which is going to be, let's see here, on this one we got the thermostat Y from the thermostat that connects in the same terminal block for the AC, and then we have our power, which is R, and that's going to the thermostat as well. And then we have our G wire, which is our fan, okay, and that's going to the thermostat as well. And we have our W wire, which is always going to be for heat, and that's going to the thermostat as well. The R wire, that's our most important wire on this control board, because what happens with this is that this board sends out 24 volts, okay, and that 24 volts is going to run through the thermostat. And what happens is on that thermostat, depending on the temperature, whether it's satisfied or needs heating or cooling, it allows that 24 volts to run through the thermostat. It kind of makes a switch and allows like a bridge, and allows that 24 volt wire to run through the thermostat and come back to the other wires. So it's all those other wires like the Y, the W, the G, those are all basically the red wire, but it's sending it back through the thermostat, and when it gets to this board and gets that terminal, that's when it energizes either the cooling or the heating or the fan. So it's good to know that the thermostat, all it is just a temperature switch. It's just allowing that red wire to come back to a certain place on that board. Okay, and also on this board we have a fuse. So if this fuse was popped, this is our 24 volt fuse. If that was popped, then I probably have a nick on the wire, or the wire's touching metal somewhere. So I want to find out, why did that fuse pop? what went bad. It's more than likely I have a short in the system that I have to find, and the way to do that is ohming out the thermostat wires, and we can kind of go through that and look at that, ohming that out in a second. Beyond this, in this area, we're going to have our transformer. Okay, transformer down here. It's kind of hidden away. So back here, under here, this is going to be our 120 to 24 volt transformer. And obviously it sounds similar to, I mean, from what it's called, it's similar to what it does, right? It transforms the voltage. So it takes the 120 volts from the outlet and transforms it to 24 volts. And then there's step down transformers that takes a higher voltage and transforms it down. And then there's step up transformers that takes a lower voltage and steps it up. You know, and a lot of times you'll see that more commercially. But on the step down, this is going to be a step down right here, and this is more for residential. This one's basically going to be 120 to 24 volts. And we do get some for repairs that we keep on our truck that are universal. And it's not that it steps it up, the ones we keep step it down, but it does different voltages, like 120 volts or 240 volts. And I believe this is the 440 volt as well. So there's that. What we have on this transformer is going to be a white wire and a black wire. And this is going to be our neutral wire. The white wire is neutral, okay? And the black wire is going to be 120 volt power wire to the board, okay? And actually, I'm sorry, just take a step back here. So the power comes in from the outlet into the furnace. It goes through this door switch, okay? This door switch stops the power and allows the power to pass over into the furnace. So once we put this panel on, the door switch says it's safe to operate. There's no homeowner that has their hand in here and their hand's gonna be sucked in there. So it's basically a safety switch so people don't get hurt. So when this door, when the door panel is open, it stops all the power to the furnace. When it's closed, or if we're working on it, I can put some tape on here or something to hold it. And I believe they sell magnets that will actually hold it for service guides. So power will run through here, and then after this goes into the board. And then from the board, then that's when it runs in through the transformer as well, for the 120 volts. And then it comes out of the transformer, 24 volts back into the board. And it feeds the board the 24 volts. You know, so you have your LAD and you have your limit switches and stuff there. But it also mainly, you know, allows the thermostat to take that 24 volts and send it back to the relays. Okay, I'm just example of where that transformer is. As well, in here we have our, let's see, down below this is our burner assembly. So these are going to be our burners. Okay, this is where a lot of the magic happens for the heating side. You know, if I'm not heating and I'm just cooling, the thing that's going to run on here is the motor. You know, we're going to have our motor running, our capacitor is important, our transformer, our board, all that's important. Mostly everything below this is all going to be for heating. So in the summertime, all this stuff will not be running. But this, the blower, the control board, all that will be working and running for the air conditioner that's going to pump the refrigerant. We'll talk about that in a minute. But here in our burners, we have a couple items in this burner section. What's important to remember is when you're doing maintenance, that all your burners are clean. You know, I'll take like a paintbrush and brush it out, and then have a vacuum so I don't get the house dusty. And then I'll just get this a little bit clean in here. And then what I want to do is go to the flame sensor, and the flame sensor that's back here. What this does, this basically senses the flame, just like it's called, flame sensor. And the reason why that's important is when the system fires up for the first time, and the flames are lit, if the last burner is clogged or there's something going on in here, or maybe the gas valve opens up and it doesn't light, the flame is not going to be detected. But even if it does light and we got a blockage or something here and the flame doesn't, let's say doesn't get to the last burner, then it's not going to be detected. So what happens is this flame sensor will tell the control board that there is no flame, so please shut down the gas valve and don't allow the system to run. It'll try it a couple of times. I believe it's 3 times, but it's more of a safety mechanism to make sure that the gas valve doesn't continue to run, so there's obviously not an explosion and nobody gets hurt. So on this flame sensor, what we run into quite a bit is that they get dirty after running all year long. So what happens is when you go to start the system up for the first time in the season, or maybe it's one time and then it's trying to fire up a few more times throughout the day or the week, we get a service call, and it's usually that the system is turning on and shutting off, and trying to fire, or eventually it gets locked out. And that's because of flame sensors. One of the conditions, or one of the situations that it could be, is a flame sensor, locking the system out. So you look at this flame sensor, like this one here's a little bit dirty. So you could take a little bit of emery cloth or the mesh, not the regular sandpaper, the one that the mesh is used for plumbing, or some people say a dollar bill they use to clean this off. But the mesh, in my opinion, that's what I use to clean the flame sensor. So we would clean that off and put that back. Now this sends a reading back to the board. It basically creates a really low millivolts, I believe, or I'm trying to say, I believe it's 0.5. And some of them, I believe, are 0.3 or 3 milliamps. We've got to check on that, but we'll take a look at it and see what it's reading on this one. Okay. So let me set this here. I don't know if I have some mesh in my bag, but we'll see if we have it. Look. So I do. Okay, so you got that a lot cleaner. It's nice and shiny. I'll go ahead and place that back in here. Sometimes they're a little tricky to get in there. So. Get that in place. And I have it written down as far as the milliamps and the voltage and my notepad and my book. I'll get that for you before we end this conversation here on this topic. But we'll get back to this here in a second. So after that, we have our igniter. You'll have a couple different types of igniters. There's a hot surface igniter, and there is going to be a spark igniter. And so we're going to go ahead and show you that. And you got to be very careful on these hot surface igniters because they're very fragile. Matter of fact, I'm not even going to take this one out. There's no need for it right now. Really, yeah, you know what? Let's do, because I think this one is going kind of bad here. This would be something we also want to recommend. Let's just hope this doesn't break on us just for taking a look at it here. barely touch them and they break. So if we take a look at this one, we can see that there's some changing in the color there is turning white. Typically what that means is the igniter is kind of going bad. So that's a good indication if we see a lot of that. If you don't see this nice shiny color here, you see more of this discoloration. I don't know if, I think the word I might use for that is oxidizing, but it's starting to wear and tear, getting wear and tear in there. So let me go ahead and disconnect that, because one of the things that every igniter actually has a reading on there that you need to read, and it's going to be different for a lot of these different manufacturers for different igniters, and there's charts online that you can get the readings, and what we're looking for is resistance in the actual igniter, and we'll be able to read that with our meter. So be careful with that. So I believe that 50 to 71 ohms on these Norton M igniters is what it was, and again I wrote that down in the book and we can verify that. And what I'm going to go to is, on this one I'm going to go to read. I can use, I like to use resistance, and my meter is dying here. See if it's hard to read that or see that right there. Yep, it's dying here, so. We'll probably need to get some batteries for that. I'm going to set this aside. Let's see here.
Originally, that was just supposed to be only included good. So we all decided when the first one issued
See if we have a battery right quick.
Yeah, I don't give a shit how you finish the restroom, but then you said, that's funny. And then that same guy was, I go back to my picture, goes to the rack. And he was, oh, that's where our thing was down. He was like, that beautiful mark. Yeah, but originally that was a